Alright, you guys, well, this is Unit 3A, pages 1 and 2. I'm going to work the evens. So, this review is all about exponents, polynomials, and monomials. Polynomials means there's more than one group. Monomials mean there's just one group here. So the first thing it says is state the degree of each. And so the degree is always the highest exponent. So here, the degree would be 5. And on this one, the highest exponent is 2. For number 4, we want to simplify. And the first thing I like to tell my students is simplify your whole numbers first, then go to the x's and simplify those, and then the y's. So simplifying the whole numbers, 8 divided by 4 is just like normal, which is 2. And he goes on top of the fraction because 8 is more than 4, so he stays on top. Then I simplify the x's. The x's are all on top. They have nobody to simplify with on the bottom, so they stay as x squared on top. Then I subtract my exponents here because remember, math's RM. When you're dividing, you subtract the exponents. So 8 minus 4 is 4, and there's more on bottom, so y to the 4th goes on bottom. And that's your simplified answer. For number 6, we're multiplying, and we're raising. So the first thing I want to do is raise. Exponents first, right? PEMDAS. And then I'm going to multiply through. So when I'm raising exponents to another exponent, I multiply them. I get to distribute this 3 to the 8, to the C, and to the D. So I'm just going to rewrite this as 1/2, parentheses, C squared, D squared. And then I'm going to add, or rewrite, this parentheses with that 3 distributed. So you get negative 8 cubed. C has like an invisible 1 right there, and so 1 times 3 is 3, so you get 3 cubed. And then D to the 5th cubed, I multiply those numbers to get D to the 15th. Now I want to go ahead and simplify this in my calculator, and make sure whenever you're putting in negative numbers, you always put them in parentheses before you raise them. I'm going to put negative 8 cubed in my calculator, and I get negative 512. So this is the same thing as 1/2 C squared D squared times negative 512 C cubed D to the 15th. From here, we're just multiplying. And when we multiply, you want to multiply your numbers first. These are called the coefficients, the big number in front. You want to multiply those first, and they multiply just like normal. Negative 512 times 1/2 is going to be negative 256. Then you multiply your C's. Now remember, when we multiply, we are going to add the exponents. So C squared times C cubed is C to the 5th. Then D squared times D to the 15th becomes D to the 17th. And that's your final answer for number 6. Moving on to number 8. Same thing here, we are just simplifying. We're dividing, so remember maths RM tells me that if I'm dividing, then I'm going to subtract my exponent. But remember that you treat your coefficients, those numbers in front, just like normal. 12 divided by negative 2 is negative 6, and he goes on top because there's more of the whole number on top. Then I simplify to b's. I've got b cubed on top over b, so I subtract those exponents. 3 minus 1 is 2 so b squared goes on top. Then I've got c to the first over c to the first. 1 minus 1 is 0. So these guys cancel each other out because they're the exact same thing on top and bottom. Notice when I don't have anything on bottom of my fraction, then I can just box this up as my final answer. Negative 6b squared. Number 10, we're transitioning into scientific notation. It wants us to take number 10 that's written in scientific notation. It wants us to write it in standard notation. That just means decimal or whole number notation. Make it look like normal. So I have 2.16 times 10 to the negative 4. Whenever I see a negative exponent, I know it wants to make this number smaller. So I go to the left 4 places. 1, 2, 3, 4. And I add zeros. So I have 0.000216 as my final answer. Number 12, I want to take this regular number and write it in scientific notation. Whenever you have scientific notation, you always want one digit in front, the decimal, and then the other digits. I don't have to write all those zeros because what I'm going to do is write it times 10 to the something. Now, then you have to decide if you're going to have a positive exponent or a negative exponent. A positive exponent would make this 4.3 really big. A negative exponent would make this 4.3 really small. So I want it to be like this number, so I want it to be a positive exponent so that 4.3 becomes really big like this number. So I look at 4.3, it'd be right here, and I count how many decimal places I need to move over. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4.3 times 10 to the 9th is going to give me 4,300,000,000, like that number. So this is my final answer. Number 14 is asking us to write this fraction in scientific notation. Notice it's already kind of in scientific notation. It's got the top in scientific notation and the bottom. And what we know here is that we can treat these whole numbers like normal and divide them out. And then we can treat these base 10s using our exponent rules. So remember, when we're dividing, we subtract. So the first thing I want to do is 8.4. 8.4 divided by 1.2 equals 7. So I'm going to write 7 times 10 to the something, right? Remember, we subtract our exponents here. So 4 minus 3 is 1. So my answer is 7 times 10 to the 1. Double check to make sure this number right here is in scientific notation. It is, because it just has one digit in the ones place. If you wanted to rewrite it as 7.0 times 10 to the 1, you could also do that. But that will be your final answer. That's it for pages 1 and 2 evens. Come in if you have any questions.